In today's lesson, we're going to continue to look at angles. Today we're going to look at the angles inside a triangle. Kind of a cool pattern that exists here. It turns out that when you have angles in a triangle, regardless of the shape of the triangle, the three parts on the inside, x, y, and z, let's call them, always add up to 180. That's going to turn out to be our favorite number. Straight lines make 180. Triangles make 180. There's actually some other patterns that make 180. Kind of cool. Why do we like this? Well, if we know any two of the three angles, we can solve for the third one. Kind of like we did yesterday when we had a line being divided into parts, call that x, y, and z. Well, if I knew two of them, I could figure out the third one. Show you how this is going to work. So I want to find the unknown angle. It's right here, x. Well, I know that 50 plus 80 plus x has to equal 180. Has to. So I can solve this by putting the numbers on one side and the letters on the other. When I cross the equal sign, I do the opposite, right? Well, doesn't this look like our shortcut from yesterday? 180 minus the parts that I know. Turns out that x must be 50. So I can kind of cheat and skip to this step because I know they have to come out to 180. If I get rid of the parts I don't want, subtract them, I can figure out the missing part. Let's try B here. Here's my angle x. Well, x is part of a triangle. I know triangles make 180. If I subtract the two parts I already know, I can find the missing part, 110. And the third one, what we got here? It's still a triangle, so I can find missing angle x. 180 minus 45 minus the other one. What is the other one? It's a box. That's a trick way of telling us an angle. We know that's 90. So if I subtract them all, I get x is 45 degrees. Okay, pretty quick to do this, right? Now, let's take a look at some special triangle situations. Situation number one, called an isosceles triangle. You might remember that name from grade 8. Okay, it has two equal sides, which are shown by dashes. So if I have a triangle and it has two equal sides, I'm going to put a dash on them. Say, hey, those two things are the same. Well, it turns out that the angles across from the equal sides are also equal. So here's a dash. Across from it is letter x. Here's another dash. Across from it is also letter x. They have to be the same. So if you ever see a triangle that's got two x's in it, that means you have two sides are the same. Or if you see two dashes in it, it's got two angles are the same. Let's go back for a second. Take a look at some of the ones we just did. Well, it turns out, in this last question down here at the bottom, that x was 45. So if I put a 45 in here, because that's what we solved it to be, right? Here's my 45. Well, that means this angle and this angle are actually the same, which means this side has to be equal to this side. We could put some dashes in there. It's an isosceles triangle. If you go back to part A, can you put the dashes into the diagram that are also the isosceles triangle? X was 50. So this is 50 and this is 50. Two the same. Across from it. It does matter which side gets the dashes because it tells me which angles are the same. Well, this is a really powerful kind of idea because it can allow me to solve triangles that have one angle given in them. So let's take a look at these examples. I notice I got some dashes, dash 1, dash 2. Across from this dash, I've got an x. Across from this dash, I got an x. How do I solve this triangle? Well, we know that x plus 30 has to come out to 180. Triangles always make 180. So how do I solve this? Bring the 30 to the other side, and x plus x makes 2 x's. So I can collect my like terms now. I don't want 2 x's, I want to know what x is. I divide by 2. Whatever I do to one side, I do to the other. It turns out x is 75 degrees. Okay, so I can actually use algebra when I talk about angles. Let's try the next one. I got a dash. It's across from, a 65. Another dash. It's across from, well, didn't we say things that are across from each other are the same? So if this is 65, that one's got to be 65 because it's one of the angles across from an equal side. So all I'm really missing here is 1x. What do I know about triangles? I know that triangles make 180. So if I have 2 of the 3 sides, I can simply subtract them to get the remaining one. I didn't have to use this tricky idea because I actually knew 2 of the 3. I only have to use this tricky idea when I have 2 missing angles. Okay, let's try the third one. See if you can do it yourselves. Got a 40. That's across from here. I don't know it. That's across from here. I don't know it. Oh, I've got 2 x's this time. So x plus 40. That's 180. Or if you will, we can kind of cheat. If there's 2 x's, don't we know that 2 x's have to be equal to whatever's left over? In this case, 140. Like, I can take the 180 and subtract it, 40 from it, and I know I have 2 x's. X has to be 70. So I can kind of cheat. I don't have to write out the equation. I can probably skip to this step, or actually this step is probably better, that I have 2 x's and they're equal to whatever is left over for that triangle. Okay. That's idea 1 and 2. Here's idea number 3. Let's put together the stuff we know previously. What do we know previously? We said that a line is met by another line. The 2 angles that meet have to make 180. Why is that important? Well, if I turn this into a triangle, now that I know x, I can maybe get y. Now that I know y, I can maybe get something else in the triangle if I knew something else. So I can problem solve with this. Here's how this is going to work. Let's take a look at the first one. Okay, in this first one, what do we see? I definitely see a triangle, but I only know one of the 3 angles, so I can't solve the other 2. But I also see that I have a straight line being met by another line. I know those 2 angles have to make 180. So I can take 180 and subtract 122 and get x. Well, now that I know that x is 58, let's put that in our diagram here. Don't I have 1, 2 of the 3 parts of the triangle? I can get the third part because I know triangles make 180. If I subtract the 2 parts that I know, I'll be left with the angle that I want, letter y. So we're going to use angles that are inside the triangle, interior angles, and angles outside the triangle, exterior angles, to solve things. And our clue is to look for straight lines and triangles. Let's take a look at this one. Here's a straight line being met by another line. I can figure out this angle. This angle has to be 180 minus 120. It's got to be 60. And similarly, here's another straight line being met by another straight line. I can find this angle, 180 minus 76. That's 104. Now, it didn't ask me to find those. It only asked me to find x. But I can't really find x without knowing those 2 angles because in my triangle, I didn't know any of the angles originally. But now, I know 2 of the 3. X has to be 180, take away the 60, take away the 104, whatever's left over, 16 degrees, has to be the third angle in the triangle. So I use some outside stuff to find some inside stuff. I'm going to try one more. Tricky one here. All kinds of letters in this one. When I look at this diagram, the first thing I notice is I got a whole bunch of things going on. I got some triangles. I got a small triangle. But I also have a big triangle. But I also got a straight line. I've also got some straight lines right here. Look at these ones right there, right? Straight lines. So I got all kinds of things. Before I even notice all that, the first thing I noticed in this, I saw some dashes. I like dashes. Dashes give me clues of things. things across from your dashes have to be equal. Well, that's got to be 65. If I know 2 of the 3 parts of a triangle, can I figure out the third part? Absolutely. V is 180, that's my whole triangle. Take away the 265s, it's got to be 50 degrees. Okay, so I've got some stuff figured out. What else can I figure out? I can figure out x and y actually because they're being met by a straight line. What do I know about straight lines? I know they make 180. So y has to be 180, take away 65 is 115. Now it turns out, I'm going to have to do some erasing here. It's getting kind of messy here. It turns out that x is actually the same. How come? Well, there's your straight line. It's got a 65 and an x. Isn't that the exact same math? 180 minus 65 makes 115. So I've got 3 of the 5 letters. Ooh. What else can we get? I'm going to do some erasing here just so we can see stuff again. I'm going to put some numbers in here because we know some things. Y was 115, X was 115, this was 65, and this is 50. Okay. How can we get W? W. W is a bit tricky. In W, I got to think about this big shape that I see here. What big shape is this? That looks like a triangle to me. And I know 1 angle, 2 angles, and want the 3rd angle in the triangle. Well, I can do that if I know about triangles. They make 180. If I subtract the 2 parts that I know, you should get 59 for the 3rd part. How can I finish this off? Well, to get Z, here's a straight line being met by another line. What do I know about these 2 angles? I know they have to make 180. Oops, not W, Z. So Z has to be 180. Take away 59 for W. Comes up to 121. Okay, so we're at the tricky part now. This is not easy. There's lots of thinking going on here. The math is pretty easy, right? We're just adding and subtracting whole numbers. They're always positive numbers. But we have to actually see what's going on in the picture. That's the hard part. Okay, the key is to look for straight lines and triangles. If I can find those, I know they make 180s. Okay, try this sheet on the website. That's our lesson for today. The first ones are pretty straightforward. The second half of the page is a little bit trickier. Give them a try and see what you can do.